Hey class, happy Friday. So if you're watching this video, that means that you did not make it to the review session today in the Google Hangouts, which is a shame because it would have been nice to kind of check in with everybody. So this is what we did today, right? We're doing this quadratic equations review 2. All right, we're going to kind of review both simplifying radicals as well as solving quadratic equations using inverse operations. All right, so first things first, right? To simplify radicals, right? These are kind of the steps here. We've seen these before. We talked about these the last couple of weeks here, right? We always want to look for the largest perfect squares that is a factor of a number inside the radical, right? And these are those perfect square numbers that we need to look for, right? 1, 4, 9, 16, 25, right? Those are my perfect square numbers that I need to find. All right, so then we're going to use this multiplication property of square roots to break up the radical, right? We're going to take that one radical expression and break it up into two radicals using this multiplication property, right? Or the square root of a here, right? This is going to be your perfect square factor times some other factor. All right, and then we want to simplify the square root of the perfect square and leave any factor that is not a perfect square inside the radical. All right, so here we go. And sometimes, right, we have to use that multiplication property to go the other way as well. We're going to smash some things together here, right? All right, so we have the square root of 72 here. So that means we need to break this up, right? And to figure out what number we got to break up 72 into, right? We're going to use a calculator and we're going to use those perfect square numbers, okay? So we're going to take our calculator and we're going to type in 72 here, and we're just going to divide down the line here, right? We're going to see which one of these perfect square factors can evenly go into 72. All right, and we want to start up high and kind of work all the way down. All right, so looking at the number 72, right? Well, 81 is too big, 64 is not going to work. So maybe I try 49, right? So 72 divided by 49, 1.46. Nope, that's not going to be it. So then I try the next biggest one, which is 36. So let's see if 36 goes into 72. And it does, right? It's 2. So that means my rad 72, I am going to break it up into rad 36 times rad 2. And this rad 36 is my perfect square, right? Square root of 36 simplifies to 6. So then my final answer is 6 rad 2. All right, an example 2 here, right? We have the rad 7 or square root of 7 times the square root of 14, all right? So in this problem, right, this is the one that we want to smash together first, right? We want to multiply these together. So we want to bring those two radicals together with multiplication. All right, so we're going to multiply 7 times 14. All right, since they're inside the radicals, right, anything on the inside can go together, just like anything on the outside can go together. So here we get the square root of 98. All right, now the square root of 98, this is what I want to break up into a perfect square factor times the non-perfect square factor. Right, so again, to do that, right, we're simply just going to take your calculator, start with that 98, and kind of work down the line here. All right, so 98 divided by, well, 81's too big, 64 is not going to work, so I'm going to try 49, and we get 2 again. All right, so that means the square root of 98, right, we're going to break up into the square root of 49 times the square root of 2, where this square root of 49 is my perfect square. So this square root of 49 turns into a 7, and this rad 2 stays a rad 2. So my simplified answer is 7 rad 2. All right, and our last one here, right, we have 2 rad 5 times 3 rad 10. All right, so here we have some outside numbers, the 2 and the 3, that are going to be multiplied together because they're just on the outside, right? And then we also have this rad 5 times this rad 10, and those are both radicals, so I can multiply those together as well. So 2 times 3 gives me 6. Right, this rad 5 times a rad 10 is a rad 50. All right, so now again, I have a radical, so I need to break it up. Right, anytime we have a radical, we need to break it up into a perfect square factor times another factor. All right, and the 6 is simply going to stay out in front for now. Right, and it's going to be multiplied with something at the end here. All right, so for my rad 50, right, I'm going to break up into the rad 25 times rad 2, and my 25 is that perfect square number. So the square root of 25 turns into a 5, All right, this 6 is just going to drop down, and it's going to get multiplied, right? And then times this rad 5 is going to come down, right? Because this rad 5 is not a perfect square. So now I can just multiply my outside numbers, right? A 6 times 5, I can do that. Is 30 rad. Oop, that was not a rad 5. That should be a rad 2 here. Rad 2, rad 2, rad 2. So my final simplified solution is 30 rad 2. All right, so now we're going to kind of review this week's stuff with solving quadratic equation using inverse operations. All right, so to do these, right, these are kind of the steps for these types of problems, right? We want to isolate that quadratic term, right? So we're looking for either that x squared or x plus a some number squared, and then we're going to use inverse operations. All right, we isolate it. And then once we isolate it, then we're going to take the square root of both sides of the equation. And when we do that, right, we don't want to forget that plus or minus sign. Right? Very important because it is a quadratic equation. We're going to have two solutions. And then we're going to simplify the radical expression and make two equations if needed to finish solving. All right. Sometimes I need to make two equations, and sometimes I just need to simplify the radical, and I'm done. All right. So we'll look at both type of examples here. So this first one in example 4 is just x squared is equal to 12. Right, so in this case, my x squared is isolated, right? There's nothing on this side of the equal sign. So now I'm ready to go to step 2 by taking the square root of both sides. All right, so now when I take the square root of both sides, right, this x squared just becomes an x because the square root gets rid of that x. All right, and because I took the square root to both sides to solve, it now turns into a plus or minus. All right, and now I got to simplify my radical, right? This rad 12 is not a perfect square, but I can break up that rad 12 into a rad 4 times a rad 3. All right, and again, I'm doing 4 times 3 because 4 is my perfect square number. So now when I can finish simplifying this as x is equal to plus or minus 2 rad 3. All right, in example 5 here, we have 2x squared is equal to 90. All right, so in this case, I need to isolate my x squared because there's a number out in front of it, right? And it's being multiplied by 2. So to do inverse operations to isolate it, I would have to divide by 2. All right, and when I do to one side, I have to do to the other side. So I'm going to divide both sides by 2, and we get x squared is equal to 45. All right, now that my x squared term is isolated, now I'm ready to take the square root to both sides. All right, again, my square root gets rid of my square, so this turns into x on my left side equals plus or minus. And now my rad 45 is not a perfect square, so I have to break up this rad 45 into a perfect square number times another factor of that. All right, so this rad 45, I'm going to find the largest perfect square that goes into 45. All right, again, just using this list of numbers, all right, your perfect square numbers. So you take 45, then you start dividing down the line. Well, I know 36 is not going to work. I know 25 is not going to work. So I'm going to try 16 first. Nope, and 16 doesn't work, right? Again, I want to start with the biggest numbers that can possibly go into it and kind of work down because I want to find that largest perfect square factor. All right, so then 16 didn't work, so I tried my next one down, which is 9. And 9 is a factor of 45, right? 9 times 5 is 45. So there we go. So I'm going to break up this rad 45 into rad 9 times rad 5. And now I'm ready to finish simplifying this. So x is equal to plus or minus 3 rad 5. All right, a couple more to do here. All right, number 6 says we have x squared minus 2 is equal to 30. All right, again, if you look on the top there, right, those are your list of perfect squares. All right, those are the numbers I need to find when I'm simplifying a radical here. All right, and again, I didn't mention this, but hopefully you printed this out or you're writing down these examples and doing these along with me. All right, so 6 is x squared minus 2 is equal to 30. So here, right, I need to add 2 first to both sides to isolate my quadratic or my x squared term, right? So now I get x squared is equal to 32. All right, now that this is isolated, now I'm ready to take the square root of both sides here. All right, again, my square root gets rid of that squared. So we get x is equal to plus or minus. All right, so now this rad 32, that is not a perfect square. So that means I have to break up this rad 32 into a perfect square factor times another number, right? It's the other factor of 32. All right, so again, I want to start by finding the largest one first. All right, it'll make it a lot easier if you find the largest one and not just any old perfect square factor. All right, so again, you start with the number 32, and you kind of just divide down the line. Well, 25 doesn't work. I know 16 is not going to work. Let's see if 9 works. Nope. All right. Well, I did not try 16. I probably should have tried 16 because 32 divided by 16 is 2. All right, so 16 is the largest perfect square factor. All right, 4 is a factor of 32 as well, but I want to find the largest one because it'll make me have less steps to do here. All right, so this is that largest perfect square is 16. So now my final simplified answer is x is equal to plus or minus 4 rad 2. All right, number 7 looks a little bit different from the previous 3 we just did, right? Because this is the one that has a parentheses around my x with that squared, all right? So these are the types of problems you're going to have. You're going to have to make those 2 equations, all right? So this is my quadratic term. All right, it is isolated because there's nothing on the outside of this little squared number. So now I need to take the square root of both sides. All right, and again, this square root gets rid of that square. So now on my left side, I get x plus 2. But now on my right side, right, square root of 25, that is a perfect square number. So that equals plus or minus 5. All right, so now to finish this type of problem off, this is where you get to make your 2 equations, right? So we have to say that x plus 2 is equal to 5, or x plus 2 is equal to negative 5. All right, and now I simply solve these both the same way, right? By subtracting 2 to both sides. So x is equal to 5 minus 2 is 3. That is one of my solutions. All right, and same thing here. I subtract 2 to both sides here, but this time a negative 5 minus 2 is negative 7. So you get x is equal to negative 7 as my second solution. Awesome. All right, we just got 2 more to do here. All right, number 8, we have 2 times x minus 3 squared is equal to 98. All right, again here, this is my parentheses one, all right, and I do have a number outside of my parentheses, so therefore I have to isolate it. I have to get rid of this 2. All right, and to get rid of that 2, I would have to divide it because right now it's being multiplied because it's right on the outside next to it. All right, so I'm going to divide this side by 2. I'm going to divide this side by 2. All right, so I get rid of that 2. So now I have x minus 3 squared is equal to 98 divided by 2 is 49. All right, now my quadratic term is isolated. So now I'm ready to take the square root of both sides. All right, again, I take the square root to get rid of that square. So now on my left side, I have x minus 3 is equal to, and because I took that square root, it's always a plus or minus. And the square root of 49 is 7, right? This number is a perfect square, so I can totally simplify it there. All right, now that I have my next step here looks like this, right? I have equals plus or minus 7, so this is where I need to make 2 equations. So I have x minus 3 is equal to 7, and I have x minus 3 is equal to negative 7. So now I have to add 3, I add 3, and we get x is equal to 10 as my one solution. And again, on this one, I'm also going to add 3 to both sides. But now I have a negative 7 plus 3. So here I get x is equal to negative 4. All right, in our final problem here, we have x minus 5 squared plus 7 is equal to 16. All right, again, I have to isolate my quadratic term. All right, so I got to get rid of this plus 7. All right, and to get rid of a plus 7, I have to subtract 7, right? This is my inverse order of operations, or my inverse operations here. So now when I subtract 7, I'm left with x minus 5 squared on my left side is equal to 16 minus 7 is 9. So now I'm ready to take the square root of both sides. And again, the square root and does the square, so I'm left with x minus 5 is equal to plus or minus 3, right? Because the square root of 9 is 3. That is my perfect square number. All right, so now I'm ready to make my two equations. X minus 5 is equal to 3, or x minus 5 is equal to negative 3. So now we add 5, we add 5, you get x is equal to 8. Right, 3 plus 5 is 8. We add 5, we add 5. X is equal to, well, negative 3 plus 5 is a positive 2. So then those are my two solutions. All right, so hopefully this is making a little more sense. So now you can go ahead and do the quizzes. All right, nice job. You got one more week to go. All right, you can do this.